We're going to be solving 100 most difficult MCQs of chemistry, O-levels and IGCSE. In the previous part of this video, I've solved the first 50 MCQs I found in the last 10 years, I guess, that were really a brain teaser. And now, today we're going to start with the remaining 50. Okay, 51 question. 10 cm cube of propane is burned in 70 cm cube of oxygen in a closed container. So we have 10 cm cube of this fella and we have 70 cm cube of this fella. Now, when they always remember this thing, whenever you are given with the quantities of both the reactants, remember, that's 100% I can say that 99% times one is gonna be the limiting and the other is gonna be excess. I don't know the question, I'm reading it for the first time, but I know that since they're telling us both the reactants, there's gonna be something about limiting and excess. Okay, we are forming carbon dioxide and water. What is the total volume of the gas present after the reaction? Now, this is going to be a brain teaser for all the kids that don't understand that when we do a reaction, we don't use up all the things we put up. Sometimes things are left behind, okay? So over here, always remember, first thing I'm going to tell you, the point number one that in this reaction, you should know is that in gases, mole ratio, this is like the golden rule. Mole ratio equals to the volume ratio. This thing is only true for gases. Okay? And we are dealing with gases. Propane is a gas. Oxygen is a gas. That means if we have 1 cm cube of propane, since the mole ratio is 1:5, we're going to use 5 cm cube of oxygen. And if we have 10 cm cube of propane, since the mole ratio equals to the volume ratio, we are going to use 50 cm cube of oxygen. And the important part is not this. The important part is we have 70 cm cube. But for 10, we only need 50 because the mole ratio is 1:5. That means we're only going to use 50. What is the remaining 20 gonna do? It's going to be left behind. It's going to be remain unused. Okay? So over here, we're only using this much. Now, remaining amount of oxygen. Remaining O2 is going to be 70 cm cube. That was the original amount minus the 50 cm cube that we used. 50, 60, 70, 20 cm cube is the excess oxygen that is left. Now, the problem is we are not only dealing with the amount of oxygen left. The question is very important. The question says, what is the total volume of the gas present after the reaction? We need the total volume of the gases. How many gases do we have? We have one gas, O2, that was left behind. This propane gas, it was all used up. The 10 cm cube was used up. This 50 was used up, 20 was left. And then we have a third gas in the reaction. That is carbon dioxide. So if I told you the mole ratio equals to the gas ratio, we have 10 cm cube of this, we've used 50 cm cube of this, that means there's a 3 here. So we are forming 30 cm cube of carbon dioxide gas. Are you guys getting it? And after that, there's another trick in the question. I'm going to tell you that trick as well. That means we are forming 30 cm cube. We are allegedly forming 30 cm cube of carbon dioxide. The question is not over yet. Why is it not over yet? The next line, read it. Assume all volumes of gases are measured at room temperature and pressure. There is H2O, that's water. If this line was not written, room temperature and pressure was not written, then we would have considered H2O as a gas as well. But we will not consider it. Why? Because at room temperature and pressure, water is a liquid. So we are not going to consider H2O. Otherwise, 40 cm cube of H2O would also be formed because there's a 4 here. But we're cancelling it for this time. Got it? So remember this. So how many gases do we have? We have 20 cm cube of this and 30 cm cube of carbon dioxide that's formed, 20 cm cube of oxygen that's left. So in total we have 20 plus 30, that makes 50 cm cube of gases that are left, okay, which makes option B the correct answer. These are like the brain teaser questions you gotta be proficient with. Understand the tricks and tactics the examiner uses. He's just written one line to tell you don't have to consider H2. If this line was not there, then you would. So be clever. Okay, use the product table to answer this question. Which two particles have the same number of electrons? Now, electrons in ions are a brain teaser. They cause difficulty, okay? But you guys should be proficient with the fact that this is not an atom. This is an ion. An ion means it has lost one electron. This 2 plus means lost 2 electrons or 3 electrons or 2 electrons or 3 electrons. So be careful. Okay. So first we need to find the number of electrons in argon. You have to consult the product table. Argon, calcium, sodium, potassium. For some, I'll be able to like do it with myself. For argon, if you check the product table, I guess it's 18. Okay, for argon. For calcium, I guess it's 20. For sodium, it's 11 protons. But okay, I'm writing for the atoms first. For potassium, it's 19. For iron, it's 20, 26. 26, 26. Both are iron. Okay, for calcium it's again 20, and for scandium SC I would have to check it out. For SC, let's check. 1685. Okay, 1685. 21. 1685. This one. Okay, 21 electrons here. Now, what do we have to do? Electrons are lost and gained. Always remember, the protons always remain the same. Protons never get lost or gained. Proton number cannot change unless you have an alpha beta emission. Okay, so argon remains as argon. Calcium remains in calcium. But sodium plus 1 means you have 10 electrons in the sodium ion. Potassium plus 1 means you have 18 electrons in the potassium ion. Fe2 plus means 26 minus 2, you have 24 electrons. And Fe3 plus means you have lost 3 electrons. So 26 minus 3, you have 23 electrons here. Ca2 plus means you have lost 2 electrons. So you have 18 electrons here. 20 minus 2, 18. Se3 plus means you have lost 3 electrons. 21 minus 3 gives you 18 electrons. So the two particles that have the same number of electrons come out to be calcium 2 plus and Se3 plus ion. Okay? You guys mess up with the ions. You don't have to mess up. Okay, which property of a liquid ester can be used to check its purity before being used as a food flavoring? Always remember this thing. That how do you check the purity? If something is pure, I'm writing. If something, just learn this line. Something is pure, it has fixed melting and boiling point. Fixed MP and PP. That means it's fixed. If it has a range, for instance, I take water, okay, I have H2 over here that has salt in it, okay. Now the problem is that this salt is the impurity in water. So what's going to happen is that my water previously used to boil at 100 degrees Celsius, right? Water boils at 100, but because I've added salt into it, now my water is going to boil at 105 degrees Celsius. So I know that my water is impure, okay. Impurity decreases the melting point, decreases the SES, the melting point, and it increases the boiling point. Remember this. So the boiling point or the melting point is going to tell. Color does not tell anything, okay. Smell, it can be bad, you do perfume on it, it can change, doesn't matter. Solubility in water, no. Okay, gas X has the following properties. It's colorless. Okay, we know that it cannot be fluorine. It cannot be chlorine because fluorine is pale yellow. Chlorine is greenish yellow. colorless. No effect on either damp red or blue litmus paper. That means it is a every property is telling me something about the gas. It's a neutral gas. It's not acidic. It cannot be HCl. It cannot be ammonia, because ammonia is going to change the color of blue litmus paper, of red litmus paper to blue, and HCl is going to make the blue litmus paper red. These are acidic and alkaline gases, so neutral, not acidic or alkaline. Next, no effect on lime water. Lime water is only affected by carbon dioxide gas. Carbon dioxide gas forms precipitates in lime water of calcium hydroxide. Okay, it's flammable. It's a flammable gas. That means it can catch fire. It cannot be ammonia. It cannot be chlorine. Chlorine bleaches the damn litmus paper. Okay, it bleaches it. Now, hydrogen and oxygen. What do you think? Oxygen, though, supports combustion but is not flammable. Why is it not flammable? Because remember, we combust things in oxygen, but itself it is not flammable. But hydrogen, we use hydrogen in hydrogen oxygen fuel cell. And one other fact about hydrogen, if you guys remember, is that it extinguishes with the pop sound, that flame test when you add a flame into it. It's a highly combustible gas, flammable. It catches fire. So it's going to be hydrogen. That's why I said these questions are like quite tricky. Which particles contains most electron? These are my favorite questions. Okay, so first we're going to write for the atoms, and then we're going to write for the ions. So for an oxygen atom, it's 8 electrons. Okay, atom I'm telling about. Neon atom, 10 electrons from the periodic table. Sodium, 11 electrons. And magnesium, 12 electrons. Now we're going to write for the ions. For oxygen 3 negative ion means it's not conventional oxygen 2 negative. Now you know why do they do things like these? They do things like these to confuse you guys. So you guys think it's oxygen. Oh, it's gonna be a 2 negative. No, it's not what you think it is. You have to read it. Okay, so 3 electrons gained. So 8, 9, 10, 11 electrons. Neon, it's an atom, it's going to remain 10 electrons. Sodium conventionally is a positive one, but over here it's a sodium negative one. Look what's happening. You are being played with. Okay, you have to read everything carefully. Like, I cannot imagine sodium negative one they're going to give in IGCSE Olevels, but look, it is there. So it's going to be 11. 1 negative 1 means you've gained 1, so 12 electrons. Next one is even more trickier. Magnesium has lost 3 electrons, guys. Congratulations. It used to lose 2 electrons, and now everyone's gonna be like, oh, how can this happen? But this happened. Literally this happened. So 12 minus 3 is gonna give you 9 electrons. Now we have to check which particle has the most number of electrons. 11, 10, 12, and 9. Obviously it's gonna be a sodium negative one. Okay, so look, games are being played here. Oxygen 3 negative. You have to be careful. Keep your eyes open in the MCQ paper. Okay, next question. The relative formula mass of 4 compounds a given student has 1 gram sample of each compound. Which sample contains the highest number of moles of oxygen atoms? Oh, great. So first you have to find the number of moles of oxygen atom in this thing, and then you have to find in 1 gram. Okay, let's try to make sense out of things. So firstly, let's find the number of moles of oxygen atoms in 1 gram of Al2O3. So Al2O3. 1 mole of Al2O3. Now this is again a very tricky concept. 1 mole of Al2O3, I emphasize on things you guys should know. Okay, 1 mole of Al2O3 contains 3 moles of oxygen atoms. We're not dealing with molecules, we're dealing with atoms, kiddos. Remember this. Okay, so 1 mole of Al2O3 contains 3 moles of oxygen atoms. Okay, how is this possible? Okay, 1 over here, that means we have 1 mole of Al2O3. It contains 2 moles of aluminum and 3 moles of this. How do I know this? Let's make a box, and I'm going to tell you. This box, okay, this is Al2O3. Okay, now this is Al and this is Al. We have 2 Al and this is O. So we have 3 oxygen atoms. Now understand, this box is a molecule or 1 mole of Al2O3. Okay, this box is a package. It's 1 mole of Al2O3. 1 mole of Al2O3 contains how many moles of oxygen? 3 moles of oxygen atoms and 2 moles of aluminum atoms. Got it? So if 1 mole contains 3 moles of oxygen, then that means the relative formula mass is 102. 102 okay 102 grams will have, that's the mass of 1 mole, will have 3 moles of oxygen. What's the mass of 3 moles of oxygen? What's the mass of 3 moles of oxygen? 3 into 16, right? Most of a mass of 1 mole of oxygen, not oxygen molecule, we're dealing with oxygen atom, is 16. So 3 into 16. 3 into 16, look at my skills, 48. So we have 48 grams here. Now, this much mass contains this much mass of oxygen. So if we have 1 gram of this thing, we have 1 gram of Al2O3, we have X grams of oxygen. What does X come out to be? I'm going to again repeat myself. How did I make this? I saw that 102 grams, that means 1 mole of Al2O3 contains this much oxygen, 3 moles of oxygen. So if I have 1 gram, I'm going to have this much oxygen. Got it? So now what do? I simply find the value of X. X equals to 48 divided by 102. And I get the mass of oxygen divided by 102. That's 0.47 grams. 0.47 grams of oxygen atoms. Done. Now I do this for everything. Now copper oxide is 80. 1 mole of copper oxide contains 1 mole, because there's a 1 here, contains 1 mole of oxygen. Okay, 1 mole of copper oxide has a mass of 80 grams. So 80 grams contains 1 mole of oxygen, only oxygen, not O2, only oxygen, and the mass of 1 mole of oxygen is 16. So if 80 grams contains 16 grams of oxygen, if I have 1 gram of this, I'm going to have X grams of oxygen. So which makes oxygen mass 16 divided by 80 over here. 16 divided by 80. I'm finding out the mass of oxygen right now. 0.2 grams over here. Okay, so over here I have 0.47 grams, over here I have 0.2 grams. Next, H2SO4. Now I know that 1 mole of H2SO4 contains 4 moles of oxygen, because there's a 4 over here, 4 moles of oxygen. And if I have the mass of 1 mole, that is 98, how much is going to be the mass of oxygen? It's going to be 4 times 16. So 4 times 16, I get 64 grams. So if I have 1 gram of this, I'm going to have X grams of oxygen. The value of X comes out to be 64 divided by 98, and that gives me 0.65. 0.65 grams of oxygen. 0.65 grams of oxygen. Next, HNO3. I know that my 1 mole of HNO3 will have 3 moles of oxygen atoms. So if I have 63 grams of this, I'm going to have 3 times 16, 48 grams of this. So if I have 1 gram of this, I'm going to have X grams of this. X comes out to be 48 upon 63. X comes out to be 0.76 grams. 0.76 grams of oxygen atom. 0.76 grams. Now, just by looking at the mass of oxygen in each 1 gram, the 1 gram of this will have this much oxygen, 1 gram of this will have this much, 1 gram of this will have this much, and 1 gram of this will have this much. So just by looking at the mass of oxygen, I can tell, since this has the largest I am not calculating the atoms. I have to calculate the atoms, but I know this has the largest mass. Since it has the largest mass, it's going to have the highest amount of atoms. So this, simple, easy. Now again, I told you I've just compiled some really devilish questions that are gonna make you like, I don't know what. In which equation is the change in the underlying species correct? Okay. Firstly, let's look at the first question. We have to find the oxidation number for carbon. The oxidation number is in -4. How do I know this? Because hydrogen is going to be a positive one here. Why? Because hydrogen is being attached to a non-metal. And when hydrogen is attached to a non-metal, it just has a positive oxidation number. And since we have 4 hydrogens, so 1 times 4 is going to give me a positive 4. To balance out a positive 4, I need a -4. Over here, now carbon is being attached to a metal that is more electronegative than carbon. So it's going to have a positive 4 here. Why? Because oxygen always has a -2. And since it has a -2 multiplied by 2 oxygens, it's going to give me a -4. To balance out a -4, I need a positive 4. Okay. So -4 to +4. Definitely oxidation, that is correct because there's an increase in oxidation number. Next. Sulfur over here is a -2. Why? Because I told you when hydrogen is attached to a non-metal, it gets a charge of positive. Since hydrogen is a positive 1 here and we have 2 positive 1 here and we have 2 hydrogens, so positive 1 times 2 equals to a positive 2. To balance out a positive 2, we need a -2 on sulfur, right? And over here, sulfur has an oxidation state of 0. Why? Because whenever elements are free, they have an oxidation number of 0. From a -2, you're going to a 0. -2 to 0, what do you mean? You are getting the oxidation number is being reduced. -2 to 0. The oxidation number is being increased, not reduced, sorry, increased. There is an increase in oxidation number. So this is oxidation, right? Not reduction. So this is incorrect. Again, B are negative over here. That means there's a -1 oxidation, and B are 0. You're going from a -1 to a 0. Again, this is oxidation. This is an increase in oxidation number. -1 is a smaller value, 0 is a bigger value, right? So this is also incorrect. So only option 1 was correct. Which statement is correct? Okay. A mixture of liquids. These statements are gonna make you go crazy. You have to read them with very good mindset. Otherwise, you're gonna get confused. A mixture of liquids with boiling points which differ by 35 degrees Celsius can be separated by distillation. No, you cannot separate a mixture of liquids by distillation. You have to use fractional distillation to separate a mixture of liquids. Okay, fractional distillation. So this is incorrect if it's not fractional distillation. Simple distillation, you can only separate a soluble solid and liquid. Okay. Locating agents are needed to identify the colors present in ink. No, on the chromatogram you have to identify the spots. That's where you use them. The desalination of seawater to produce pure water is achieved by fractional distillation. No. Remember, whenever you have a soluble salt plus water, you have to separate the soluble salt and water. You are going to use which technique? You're going to use simple distillation. Okay, you're going to use simple distillation. But if you have mixture of liquids and you need to separate the mixture of liquids, then you are going to use which technique to separate the mixture of liquids on the basis of their fixed boiling points? Remember, then you're going to use fractional distillation. Why? Because in the mixture of liquids, each one is going to have a different boiling point. Since each one is going to have a different boiling point, you can use this technique to manipulate the liquids and then get each one separately. Got it? So this is incorrect. The RF value of a dye in a chromatogram can be calculated using the formula distance moved by the solvent, distance moved by the spot. This is also incorrect. This is also completely incorrect. And now what do we have to do? All statements come out to be incorrect. But I told you, in statement 1, the mixture of liquids with boiling point will differ by 35 is separated by fractional distillation. They didn't write the word fractional, but for distillation, now we have to consider both. We have to consider simple distillation and fractional distillation. So we're going to consider option A as correct. But in the first, if you know good chemistry, in the first try, if you try to think option A is 100% correct, that's not. There's ambiguity in option A. The ambiguity is, what do they mean? They mean simple or fractional. The truth is, it's only going to be separated by fractional. But over here, we're going to consider both, since all three options are nonsense. Okay, next. A student investigates the rate of a reaction between calcium carbonate and hydrochloric acid. Calcium carbonate and hydrochloric acid, the volume of the gas in the syringe is recorded after 1 minute. The experiment was repeated using different concentrations of HCl. Which additional apparatus are essential for this investigation? Okay, so we have to investigate the rate of reaction. For rate, we always need to measure time. So we need a stop clock. The experiment is repeated using different concentrations of HCl. Since we have to change the concentrations, okay, which addition is essential for this investigation, the volume of the gas in the syringe is recorded after 1 minute. We need a balance for measuring different concentrations. No, I don't think. For a measuring cylinder, yeah, we could measure volume by using the measuring cylinder. We don't need the fixed mass of we would need a balance for the fixed calcium carbonate. And for HCl, we'll use the measuring cylinder. For calcium carbonate, we'll use the balance and stop clock, so 1, 2, and 3. Over here, I'd like to clear a very, very, very important point. Always remember, the thing that you change, that you need to measure, you change it. Over here, we're trying to measure the different concentrations of HCl. So we're trying to measure the effect of different concentrations of HCl. Always remember, since we're gonna change the concentrations of HCl, that's a very important thing. We keep all other things constant. What do I mean? When we're changing one thing, this is like a very, I guess the biology student must know this, the independent variable and the dependent variable. When we change one thing, it becomes the independent, okay? It becomes the independent variable. The independent variable is the variable we're going to change, like different concentrations of hydrochloric acid. In the first, we're going to use 1 mole per dm cube. In the other, we're going to use 2 mole per dm cube. In the next one, we're going to use 3 mole per dm cube. The thing that changes as a result of changing the independent variable is the dependent variable. That's going to be the volume of the gas. In the first experiment, maybe we produce 10 cm cube. In the next, we produce 20 cm cube. Good. Now, the thing is that in an experiment, only the independent variable, that's the concentration, and the dependent variable, they change. All other things, like the mass of this calcium carbonate, like the volume of the acid, like the temperature, like the pressure, they need to remain constant if we correctly want to measure the effect of the independent variable on the dependent variable. That's why I need a balance to measure the exact mass. I need to keep the mass constant in each experiment so that I know that the results are being produced because of the different concentrations and not because of the different mass. I need measuring cylinder, so I know I have a fixed volume every time. The results, the amount of gas is only affected. I need to only know the effect of concentration on it, not other things, okay? And stop clock, because obviously I'm measuring it, okay? Next, some reactions of an aqueous solution of compound X are given. When a few drops of aqueous sodium hydroxide are added, a white precipitate is formed, okay? You need to know the salt analysis thing. When dilute nitric acid is added, the mixture is warmed, a gas is formed, okay? We're adding nitric acid. We are warming and a gas is formed. The gas decolorizes acidified this manganate, whatever. We know that any gas that decolorizes acidified potassium manganate, I only know sulfur dioxide gas. Okay, when dilute nitric acid is added, aqueous barium nitrate, no visible reaction occurs. That means we have no sulfate. So we have no sulfate. We have a sulfate here, cross it. We have a sulfite here, a sulfite here, a sulfite here, 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 and here. Okay. Now let's read the statements carefully. So option A is across. X contains only calcium sulfide. When a drops of aqueous sodium hydroxide is added, a white precipitate forms. For calcium, we form a precipitate, okay? X must contain aluminum sulfate or zinc sulfate. Why must contain? There's no must. Okay, X must contain aluminum sulfide, calcium sulfide or zinc sulfide. Option D. Why option D? These are the type of questions I want you guys to practice. Look, we are having a white precipitate, okay? Look, I'm gonna tell you why. Now that's the thinking process. The majority is gonna be dumb here, okay? I know, we are all humans, we do this. So white precipitate can only be formed by either aluminum, by calcium or by zinc in our syllabus. So there must be something that is aluminum, calcium and zinc. Why only calcium sulfate? Why only calcium sulfate? Or why only aluminum or zinc? There can be aluminum, there can be calcium, there can be zinc. We are not adding the sodium hydroxide in excess, and until we have not added in excess, we don't know it's aluminum or calcium, because calcium is not going to dissolve in excess, but aluminum and zinc are going to dissolve in excess. So we've not added excess, so we don't know. So it's going to be option D. There can be this, there can be this, there can be this, we're not sure. And because we're producing a gas with the nitric acid thing, that's sulfur dioxide, there's going to be a sulfite in it. And there can't be a sulfate in it because we're getting nothing with the barium nitrate thing. Got it? Next. Aqueous silver nitrate AgNO3 reacts with aqueous potassium chromate to give a yellow precipitate. What is the ionic equation for the reaction? Ionic equation does not involve the entire thing. This is not ionic equation. For precipitation, the ionic equation is very simple. You take the ions, silver nitrate reacts with potassium chromate to give a yellow solid. Okay. Look at the down ionic equation. Potassium chromate. Look at the charge on chromate. That's why I selected this question. Look at the charge. Look over here, and I need all of you guys to tell me what's going to be the charge on chromate. A potassium has a positive 1. There are 2 potassium, so we have a positive 2. To balance out a positive 2, what do we need on chromate? We need a 2 negative. Look at the last equation. There is a negative 1 on chromate. That's incorrect. Chromate ions don't have a negative 1. They have a 2 negative on them. Cross. Got it? That's why it's option C. You need 2 silvers. Each silver has a positive 1, and you need 2 silvers to balance out the charge on this thing. 1 plus gonna balance the 2 negative on this fella. You had to look over here in the question to figure out the charge. And this equation is correct because, in ionic equations, we cut out the spectator ions. We only write the ions that are there that then form the solid, okay? That's how we write ionic equation. That's completely incorrect. This is incorrect as well, okay? What contains the greatest mass of solute? Okay. First things first, we got to figure out what's the solute. Solute is going to be the thing that's going to be dissolved, that we're going to put in. So like if we have a beaker here and we add white salt into it, salt is the solute, and then we add blue water in it. Water is the solvent. Many people fail to figure out between solute, solvent. They've studied in grade 3 but they forget, and that's like really common thing, okay? So over here, 100 cm cube or 1 mole per dm cube sodium hydroxide. What is the solute? Sodium hydroxide. We have to figure out the mass of sodium hydroxide in this thing. To figure out the mass of sodium hydroxide, what are we going to do? How do we figure out the mass? We first figure out the moles. We have the volume, we have the concentration. Now you might think if it's a solid, we're figuring out the mass, then how come they have a volume? What has happened over here is that I tell you. You took 100 cm cube of water, okay? You took 100 cm cube of water. This is 100 cm cube. Then you added some mass of NaOH into that water. And when you added, I don't know the mass, that's in grams, you have to figure it out. You formed a solution that had a concentration of 1 mole per dm cube. That is what happened, okay? Now you know what happened. Now let's figure out the mass. So first, for mass, what do we need? We need to figure out the moles. No worries. moles equals to concentration into volume. Concentration is 1 into volume. Volume is 100 cm cube. We need to take the volume in dm cube. So 100 divided by 1000. 100 divided by 1000. 0.1 mole is coming out to be the moles. Now we have the moles, we have to figure out the mass. How do we figure out the mass? Simple. Mass equals to moles into mr or ar, or formula mass. Moles is 0.1. mr of NaOH is going to be, Na is 23 or 21. 23, I guess. Let me check in the product table. Okay, 1688. 23. Okay. 1688. Where's 1688? Here. Okay. So I get the MR 23 plus 16 for oxygen and 1 for hydrogen. So 0.1 into 23 plus 16 plus 1 moles into the MR. That gives me 4 grams for option number A. Next, 500 cm cube of this. I told you, what do? We find the moles, and moles equals to the concentration into the volume. Concentration is 0.05, volume is 5000 divided by 1000. So, sorry, 500 divided by 1000. That's the volume into 0.05. That's the concentration. I get 0.025 moles. Moles multiplied by the mass. Do it on the calculator. You don't need to show any working. Just be quick and do it on the calculator. Okay, sulfuric acid. Sulfuric acid, the mass is going to be H2. That is, H2 means 1 plus 1. SO4. S means 32. Okay, 32. O4 means 4 times 16. 1, 2, 3, 4. Done? 2.45 grams. For option 2, I'm getting 2.45 grams. Okay, now this. 0.1 mole per dm cube and 1 dm cube. Now again, there's a big switch. cm cube, dear. Now the people who are doing it in calculator, they're doing it in hurry. They're going to mix this dm cube. Sorry for them. So now 1 into 0.1. That's going to give me 0.1 moles. Now moles multiplied by KOH. For potassium, I guess the mass number is 39. For oxygen, it's 16 plus hydrogen, it's 1. So 0.1. That's the moles multiplied by, this time you don't have to convert the volume from cm to dm because it's already in dm cube. Multiplied by mr. For potassium, it's 39, I guess. KOH. O means 16, H means 1. And the mass comes out to be 5.6 grams. Next, 2 dm cube. So 2 into 0.01 is going to give me the mole. 2 into 0.01. That gives me 0.02 moles. 0.02 moles. I have the moles of HCl. Moles multiplied by the molecular mass of HCl. HCl is going to have a molecular mass because remember, HCl is a simple covalent gas. You dissolve it in water to form the HCl acid. It's not an ionic compound. It's a simple molecular thing. Okay, Cl is 35.5. Okay, so multiplied by 1 plus 35.5. And that gives me 0.73 grams. 0.73 grams. So the largest amount of mass I get is for my option number C. Next, bromide, and hydrogen ions react together in the equation shown. Again, you have some redox calculation, some apparatus for measuring how the rate of the reaction varies over time is suggested. You need a gas syringe. Okay, how I told you, what are we measuring? We are measuring the rate. Rate means change in whatever, in the product or in the reactant or whatever change is happening divided by time. We divide anything by time, it becomes the rate. Like for instance, I can write what do I write? I write chemistry. Okay, I have to write chemistry 5 times. Chemistry. Now if I divide the time I took to write it by 1 minute, it's going to become a rate. If I divide anything by like time, it's going to become the rate. Rate of my writing is 2 minutes per word. Okay, by the number of words I write divided by time, the time it took me. Okay, so that's going to give me the rate. of my writing. Now, I'm not very good with maths, but I just tell you whatever you divide by time becomes the rate. Reaction varies over time is suggested. Okay. Which apparatus is suitable to measure the rate of the reaction? Are we forming any gas? No, we're not. So why do we need a gas syringe? Balance and pH meter. Bromide, and hydrogen ions react according. Okay. So I need 5 moles of this, 1 mole of this, and 6 moles of this. And I only need a pH meter. I don't need a balance. What do I need to do with mass? Mass doesn't tell me the moles. I don't think I need a balance. I'm only going to go with a pH meter because look, over here I have neutral pH. Okay? Water and Br2, neutral. Over here I have acidic pH. So only if I can measure the change in my pH, how much less acidic it's becoming, how much neutral it's becoming, I can measure the rate. Okay, I divide it by time. In how much time my pH goes from because over here maybe it's a 2 because we have a lot of hydrogen ions, and over here it's a 7. So in how much time it's going from 2 to 7? In 5 minutes. So then I divide it and I know. So only 3 only, I think. We only need a pH meter. Got it? These are confusing questions, like they confuse you a lot. It's fine. 25 cm cube or 1 mole per dm cube HCl reacts with 10 gram of solid to produce a gas. Okay. The solid is in excess. Now, always remember this volume time graph. When something is in excess, it cannot make your line go above the final line. It can make your line increasing or decreasing. It can make your line more steep or less steep. But it cannot increase the amount of product. Excess reactant can never increase the amount of your product. Excess reactant can never increase the amount of product. Excess reactant can never increase the amount of product. The graph labeled first experiment shows the volume of gas produced over time. Graph P and Q show the volume of gas produced under different conditions. Okay. We have to first, the graph labeled experiment volume produced over time. Graph P and Q show the volume of gas produced under different conditions. So the first experiment that has 10 gram of the solid in 25 cm cube and 1 mole per dm cube of the HCl. Now I have to tell you a very important thing. You guys know that this thing is in excess, okay? And you guys know that this whatever thing is the limiting reactant. Now what did I tell you? I told you that only if you increase the limiting reactant, you can increase the moles, or you can increase the amount of your product. Okay, so if you increase the moles of the limiting reactant, you can increase the product. If you decrease the moles of your limiting reactant, you can decrease the product. So in line Q, the product is decreased. That means we have decreased the moles of HCl. Over here, how many moles of HCl we have? 25 multiplied by 1 divided by 1000. 25 multiplied by 1 divided by 1000. I have 0.025 moles in the first reaction. In this reaction, I have 0.025 moles. Definitely in Q, I have divided by 2. Divided by 2, the moles are halving. 0.0125 moles in Q of HCl. I don't even need to do anything. And for P, I have a higher temperature because only or something, I cannot have more concentration. No. There can't be more concentration. Because if you increase the concentration of this thing, you're going to increase the moles. And if you increase the moles, you are going to increase the product. And because this is your limiting reactant. I don't know if you guys are understanding the depth of this concept, which is very important. P uses a catalyst. Okay, it can happen because catalyst increases the rate, and Q has a lower temperature. No, dear. If you have a lower temperature, you are still going to form the same product. Rate cannot change the level of your line. Rate can make it go like this or this. Lower temperature decreases the rate. So the line becomes line becomes like this, but the volume of gas, the amount of product can only be changed if you increase or decrease the limiting reactant, so cross. Many people don't get this. Okay, P uses 25 cm cube of more concentrated acid. No, if you increase the concentration of acid, you increase the moles of acid, then your line becomes above it, because that acid is the limiting reactant. P uses a higher temperature. Yeah, that's correct, because if you have higher temperature, line is going to be more steeper, and Q uses 25 cm cube of more dilute acid. So if you are using 25 cm cube of a more dilute acid, more dilute means your concentration decreases, and when your concentration decreases, mole decreases. I told you that this Q is going to have less moles, so option C is correct, that you're using a more dilute acid, so you have less moles. P uses smaller pieces. No, yes, P can use smaller pieces, that's why the rate is more, and Q uses larger pieces. If Q used larger pieces, the curve would have been like this, that the rate decreases but the product remains the same. But over here, product has decreased, that means moles have decreased, that means you're using a less concentrated thing that has less moles. Okay, 3 dilute solutions of acid, each with a concentration of 0.1 mole per dm cube, react separately with an excess calcium carbonate until there is no further reaction. The same volume of acid is used each time the carbon dioxide produced is collected and its volume is measured. All measurements at room temperature and pressure. What are the possible identities of the acids? We have this acid, that's pH 2, this is 1.7, this is 3. So we have HCl, H2SO4. You know this one, this is perfectly sulfuric acid. Why? Because it's a diprotic acid, it has 2 hydrogen ions. Look, HCl is going to ionize to form an H plus ion and a Cl negative ion. Done. H2SO4 is going to ionize to form 2 H plus ions plus SO4 negative ions. So it gives 2 H plus. Since it gives 2 H plus, it's going to form double the amount of your carbon dioxide with the, if your that is in excess, what do you call it? Calcium carbonate. So this is sulfuric. Now we have to see what is HCl and what is nitric. I think personally HCl is like a little stronger acid, so one is going to be HCl, and 3, since it has a like we have ethanoic as well, then 1 is going to be HCl and 3 is going to be ethanoic, because it has a higher pH. A higher pH means like it does not ionize that properly, and ethanoic is a weak acid, so it doesn't ionize. So option A. Okay, selenium is in group 6 and gallium is in group 3. So selenium is in group 6 and gallium is in group 3. Which prediction can be made from this information? A gallium atom has 3 more protons than a selenium atom. No, gallium is more likely to form negative ions than selenium. Yes. No, I thought it was selenium. Selenium atoms have fewer valence electrons. No, selenium has more non-metallic character than gallium. Yes. Look, selenium has fewer valence electrons. How is this possible? Selenium has 6, gallium has 3. Gallium is more likely to form negative ions. No, think about it, gallium like aluminum, and think about selenium like oxygen. So oxygen is going to form like more negative ions. Aluminum is tend to form more positive ions. So that's incorrect. Gallium atom has 3 more protons. No, that's not. I'm actually laughing because if you look at the product table, there's going to be like a lot of difference. So that's incorrect. Selenium has more metallic character. As you move across the period, your non-metallic character increases and your metallic character decreases. So the things that are on this side, like the right of the product table, are more non-metallic. 3 structures of alcohols are shown. So we have an alcohol that has 1 OH, and what do we call it? We call it methanol. We have an alcohol that has 2 carbons and 1 OH, we call it ethanol. Then we have propan-2-ol, then we have butane-1-ol. Okay, so this is my methanol. Okay, this is my ethanol, this is my propan-2-ol. Why I'm calling it propan-2-ol? Because look, the OH is not on the first carbon, it's on the second carbon. This is the first carbon, this is the second carbon. And then I have butanol. This is butane-1-ol because the OH is on the first carbon, so you can call it as well butane 1 all. Okay. Alcohol 1 can be made by the addition of steam to an alkene. There is no, this is very funny. Why? Because to make methanol, you don't have methane. Methane does not exist. Look, methane, this is a very funny statement because you don't have methane in nature. Methane cannot exist because if it has to exist, it's going to be CH2, right? Because it has to fulfill that thing, CnH2n. So it has to be CH2, and CH2 cannot exist because the valency of carbon is not going to be fulfilled. Got it? So this is impossible. Alcohol 2 can be made from glucose. Yeah, you can make ethanol from glucose by the oxidation of glucose. You add yeast to it, and then you can make. Alcohol 3 is renewable. No, it's non-renewable. You get it from your crude oil, all this thing from the petroleum thing. Alcohol 4 is only one other isomer. Who told you one other isomer? I can show you many isomers. One other isomer can be butane 2-ol, and I show you another isomer. Look at this isomer. 1, 2, 3. This, tell me, this is called 2-methyl propan 1-ol. On the second carbon you have methyl, and that's a prop chain because there's 1, 2, 3 carbons, and that's propan 1-ol. So 2-methyl propan 1-ol. There are two other isomers you can easily make, so not only one other isomer. Okay, two equations involving ethanol are shown. Ethanol per oxygen, you have oxidation, you form carboxylic acid. Good, very good. You're going to form which acid? You're going to form ethanoic acid. Oxygen, you can use oxidizing agent like acidified KMNO4, or you can use K2Cr2O7, but the condition is don't forget the acidified part. Glucose fermentation, good. Which row is correct? Molecular formula of carboxylic acid in 1, ethanoic acid, CH3COH. What kind of behavior is this? Okay, a catalyst is needed. Reaction 2 needs a catalyst. Yeast is the catalyst. That's a living biological catalyst. So if you don't add yeast, that's not going to happen. So it's going to be 2. For 1, you need no catalyst. You just add KMNO4. An experiment is carried out to measure the rate of the reaction between magnesium and dilute HCl under two different conditions. The mass of magnesium and the number of moles of HCl are the same in both experiments. We know this because the line levels off, but 2 is a little slower than 1. Which statements could explain the difference between graph 1 and 2? Graph 1 results are obtained at higher temperature. Yeah, that can be correct because if we increase the temperature, we're going to increase the rate. If we increase the rate, the line becomes a little steeper. Graph 1 results are obtained by using HCl that is more concentrated. No, that is not possible. Why is that not possible? Because if you increase the concentration, I again tell you, you increase the number of moles. If you increase the number of moles, you increase the amount of product, and the line becomes like very high compared to this line. So you cannot have more concentrated HCl. Graph 1 results are obtained using smaller pieces of magnesium. Graph 1 results are obtained. Yes, that is correct, because when you're going to use smaller pieces, you're going to have more surface area, and when you have more surface area, you can increase the rate of the reaction. Always remember, when you increase the concentration, you increase the moles. You increase the rate, but you increase the moles as well. So that disturbs. But whenever you increase the surface area, you don't increase the moles. You only increase the rate. By increasing temperature, you don't increase the moles, so you cannot increase the product. But only when you increase the concentration, you increase the moles, because remember, moles equals to the concentration into volume. That's why. So 1 and 3, option C. A student makes 3 suggestions about the Haber process and the contact process. Only one of the process uses raw material obtained by fractional distillation of air. Contact process uses SO2 plus O2. Haber process uses H2 plus N2. Both processes one use nitrogen, one use oxygen. So not only one. Only one process involves use. No, both use catalyst, right? So the product of each catalyzed reaction has the formula type of this. Okay. Yeah, because in Haber process we form NH3 that fulfills this. X can be N and Y can be H, and for the contact process we form SO3 that also fulfills this. So 3 only is correct. Next, the table shows the energy released by the complete combustion of some compounds. Which compound releases the least energy when 1 gram is combusted? Okay, what's going to release the least energy when 1 gram is combusted? Now you need to realize the MR equals to the mass of 1 mole. Okay, so that means 78 grams is releasing, because that's per mole. So MR means MR is the mass of 1 mole, and this is the energy of 1 mole. So 78 grams is releasing negative 3270 energy. So 1 gram will release X amount of energy. I'm doing it for benzene first. X equals to negative 3270 divided by 78. Negative 3270 divided by 78. 3270 divided by 78, that gives me 41.9. So this is going to release 41.9, 1 gram. For here, just divide this by this. 4800 divided by 100. I told you the maths. The maths is 78 grams releases this much energy, because that's the mass of 1 mole, and that's the energy of 1 mole. So that means this much mass releases this much. So this much mass would release this much. 4800 divided by 100. 4800 divided by 100, that gives me 48. I could do it mentally, but like I had to use the calculator. 5510 divided by 1 and 14. 5510 divided by 1 and 14. 48.3. 48.3. 2200 divided by 44. 2200 divided by 44, that gives me 50. So which compound least energy? Most energy is going to be propane, and least energy is going to be 41.9, benzene. A. Had to read it carefully. They were asking about the least energy. So that's benzene. Next, the diagram shows the relative masses and the relative charges of two particles, this and this, present in atoms and ions. Which of these particles are present in hydrogen atom and a hydrogen ion? Okay. This particle has a mass of 1 and a charge of negative 1. So this particle is a electron, and this particle has 2000 times mass greater. Protons and neutrons have 2000 times greater mass, or you can say 1836 times. If you round it off, it becomes greater mass than your this, what is this called, electron. So this is a neutron. Now what are they asking about? Hydrogen atom. Hydrogen atom has, I guess, we have to check the product table for the hydrogen atom, and then we come back on it. 1691. Okay, 1691. Okay, so it's 1 1. That means no neutron. 1691. So this electron is present, so I'm gonna draw a hydrogen atom for you, and then I'm gonna take 1 electron out of it. So that's a hydrogen atom, dear, that has 1 proton in it. That's a proton, and that has 1 electron here. And now what do? You copy it and you form a hydrogen ion. Ion means electron says tada, bye bye, I'm going, and you have nothing. So in the hydrogen atom you have this, but you don't have this, and in a hydrogen ion you don't have this or this, so you are gone. Insulin is a protein made by the body. Which statement about insulin is correct? It's a condensation polymer. Yeah, proteins are condensation polymers because they're joined by amino acid monomers, are joined together to form your proteins. It's a synthetic. No, it's not synthetic, it's natural. Okay, when hydrolyzed, it produces only 1 monomer. No, there are different type of amino acids like alanine and guanine and cytosine. No, these are DNA bases. Like there are a lot of amino acids. There are 20 to 21. Some scientists, like, they fight on it, but like they're like roughly this much, so not 1 monomer. It contains amide linkages. Yeah, protein and nylon contain amide linkages. So 1 in 4 only. Which conversions involve oxidation? Ethanol forming carbon dioxide and water. Yeah, this is oxidation. That's pure oxidation of ethanol. Yeah, ethanol forming ethanoic acid. Oxidation again, addition of oxygen. Ethene forming polyethene. That's confusing. Ethene is you add hydrogens when you form polyethylene. Addition of hydrogen is reduction, right? So this is reduction. So 1 and 2 only. Got it? A sample of gas occupies a volume of 2 dm cube at room temperature and pressure. Which changes in the condition will both decrease the volume occupied? Temperature you would have to decrease. When you decrease the temperature, the particles move closer, right? And pressure you would have to increase. You need to decrease the volume. So, which change in the conditions would decrease the volume? See, you have a container, you increase the pressure on it, you pull the piston down. What happens to the volume? The volume gets reduced because you have increased the pressure, and you decrease the temperature, particles move. Initially particles are far apart, but when you decrease the temperature, particles are going to move closer together. Since they move closer together, what's going to happen is the volume is going to decrease. A molecule of tetrafluorosalanine, silane is shown. Only the outer shell electrons are shown. Which statement is correct? Each molecule of SiF4 has exactly 16 pairs of electrons. 16 pairs mean 16 into 2, because one pair has 2 electrons. That gives me 32 electrons in total. So for silicon, how much does silicon has? Silicon has 14, fluorine has 9. 9 times 4 plus 4. Before counting electrons, I thought of something else. Like, why should I count electrons? First, let me read other options. In SiF4, both silicon and fluorine have the same electronic configuration as neon. Silicon has 1, 2, 3, 4, 5, 6, 7, 8. 8 in its outer shell. And fluorine has 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's just like neon. But there's a problem. That silicon has 14. So when it's going to make this, it's going to have 18 in total. And fluorine has 9. When it's going to make this bond, it's going to get 1, so it's going to have 8. So it's not like neon. For silicon, it's like argon, but for fluorine, it's like neon. So this is incorrect. Molten SiF4 will conduct electricity. No, it will not, because that's simple molecular. I can see SiF4 has a low melting point. Yeah, because it's simple molecule. So this is correct. Yeah, I found the correct one. So this I didn't count, but obviously that has to be incorrect now. A student investigates the rate of reaction between calcium carbonate and hydrochloric acid. So you have your calcium carbonate here, you have your acid here. I think we've done this question. Yeah, we've done this. Let's the repeat unit of a polymer is shown. Which monomer would produce this polymer? Simple. Draw a double bond here. So if I draw a double bond here, do I get this? Always remember one thing. You know why did I put this question? I just need to tell you, if you have one carbon, that same carbon, if it has a CH3 above and H, this CH3 and H can change position. The H can go up above and CH3 can come down, but both of them are going to remain on the same carbon. The carbon that has this cannot get chlorine on it. Okay, so remember this. So one carbon that has CH3 and H, this is incorrect. This carbon cannot have CH3 and chlorine. This carbon cannot have CH3 and chlorine. This carbon has to have CH3 and H. So CH3 and H, CH3 and H on one carbon, CH3 and H on one carbon. Yeah, good. And chlorine and bromine on the next carbon, chlorine. Look, the position of H and CH3 can change, but they have to remain on the same carbon. So it's option number A. Okay. And for this thing over here, this is CH3 and Br, that's not possible. This is CH3 and Br, that's not possible. This is CH3Cl. Again, I told you the carbon needs to be the same. Element Y is in period 3 of the periodic table. It forms a chloride that is liquid at room temperature. It forms a chloride that is liquid at room temperature. I think we're dealing with silicon, which shows the correct information about the, because silicon chloride is liquid, SiCl4. But shouldn't that not be included in your syllabus? Okay, element wise in pH 3, it forms a chloride that is liquid at room temperature, which shows the correct information about the group number, group 4, and nature of oxide. Because aluminum chloride is not liquid. Nature of oxide, silicon chloride is, silicon dioxide is gonna be acidic, so that's group 6. So over here we're gonna consider group 6 because I know silicon cannot form amphoteric. It has to be group 6 because I can consider like the SCl2 or I can consider PCl5 as my liquids. I know they're not, but they can be covalent liquids. They're gonna form acidic oxides then, because non-metal oxide is acidic, but it cannot be silicon. Sulfur dioxide reacts with oxygen in air. The reaction is very slow if no catalyst is present. Which statement explains this? Because a catalyst increases the number of particles that have energy greater than activation energy. It contains 21 known, only a small proportion of sulfur dioxide and oxygen molecules have enough energy to react even at high temperature. Yes, yes, yes. Because when you add catalyst, more particles, it doesn't increase the energy. It just reduces the barrier. Like initially the passing marks for a test were 20 out of 40. What did catalyst do? It reduced the passing marks to 8. Now, since the passing marks are 8 out of 40, greater number of children can pass. So this is what a catalyst does, reduces the passing marks, so that even though initially many students got a lot of marks, they got 15 and 16, but still they failed because the passing mark was this. The energy barrier was very high, the passing marks were very high, but catalyst reduced it. Okay, which gases are used to light bulbs? Argon. Argon is used in lighting bulb, and neon is used in lightning. And oxygen, do you want combustion to happen? No. Okay, a piece of magnesium reacts with dilute hydrochloric acid. The resulting solution is then evaporated, leaving the solid residue of magnesium chloride. Which statement is correct? A covalent solid is formed in the process. A piece of magnesium plus HCl. What are you doing? You're adding magnesium and you have HCl and you're forming MgCl2 plus H2. Okay. Molecules of an element are formed, yeah? Molecules of an element, H2 is an element, so I think option D is correct. That's very tactical, that molecules of an element are formed. Many people would not know that H2 exists as molecules. Why does it exist as molecules? Because look, two hydrogen atoms are covalently bonded. Got it? Each magnesium atom loses only one electron in the process. No, 2 electrons. It's going from a 0 to a 2 positive. Each chlorine atom gains one electron in the process. No, chlorine is not gaining electrons. Chlorine is a -1 oxidation here, -1 oxidation here. Nothing is happening. A covalent solid is formed. No, MgCl2 is not going to be formed as a solid, but still if you crystallize it and form it, it's not covalent, it's ionic, because this is metal, this is non-metal. There's a transfer of electrons. Magnesium is transferring electrons. Got it? Which mass of carbon contains the same number of atoms as 16 grams of sulfur? 16 grams of sulfur is a 32. Okay, 1 second. I'm going to do it mentally because I don't want to take calculator. Sulfur is 32. You have 6.08 into 10 raised to power 23 atoms of sulfur in 32 grams. So in 16 grams, you're going to have half. So you got a half the mass number of carbon. In 12 grams of carbon, you're going to have 6.0802 into 10 raised to power 23 atoms of carbon. Okay, so if you half it, you bring it to 6 grams, you're going to have half the number of atoms, because for sulfur you are halving the mass number. For carbon as well, you need to half it. That's going to be in 6 grams. Okay, two particles K plus and AR can be written as this. Which statement about these particles is correct? K positive 1 means it has lost 1 electron. Okay, AR has okay, let's find out the number of neutrons. That neutrons is going to be this minus this. So this minus this, 0, 3 minus 1, 2, 20. This is 10 minus 8, that's a 2. 3 minus 1, that's a 2. So argon has 22 and potassium has 20. Argon has more neutrons than K plus. Yeah, that's correct. Option A. K has more nucleons than air. No. K has less nucleons. There are 39 nucleons here. There are 40 nucleons here. Okay. Incorrect. K plus has 20 electrons. No, bro. It has lost 1 electron. It has 18 electrons. K plus has greater mass than air. No. Look, the mass is going to be 39 for this and 40 for this. So AR is greater. After acidification with dilute nitric acid, a colorless solution of X reacts with aqueous silver nitrate to give a white precipitate. What could X be? Colorless solution of X reacts with aqueous silver nitrate to give white precipitate. We're giving white precipitate with silver nitrate. That means we're forming AgCl, because AgCl solid has a white PPT. So that means we have some chlorine somewhere. Chlorine. Now the problem is that it forms a colorless solution. Colorless solution cannot be formed by transition metal ions, because transition metal ions form colored solutions. So it cannot be copper, it has to be sodium. Got it? Copper is going to form a blue solution. There are like a lot of interesting things coming up. Sulfur dioxide is a gas that is prepared by heating sodium sulfate with hydrochloric acid. It is an acidic gas. Sulfur dioxide is more dense than air. Which set of apparatus would be suitable for preparing and collecting? Firstly, it is an acidic gas, so we're not going to use calcium oxide to dry it. We're going to use acid. Okay, we have acid here and we have acid here. Next problem. Sulfur dioxide is prepared by this. It is an acidic gas. It is more denser than air. Since it's more denser than air, we cannot use upward delivery. So this is a cross and this is a cross. Now, since we have to add acid with set of, acid, I don't think we're going to use a funnel to add the acid. That's not a good idea. We should use a burette so that limited amount gets, and if we have a funnel, there's going to be a problem. Sulfur dioxide gas can escape from here, but if we have a burette, we can close it. So I think it's going to be option number C. So this was a little confusing. That should be use a funnel or a burette, but look, you're producing an acetic gas, you don't want it to escape from here, you want it to transfer to this. Which diagram best represents the structure of a metal? This diagram. Now, why did I choose this question? Look, in metals, the negative electrons are delocalized. They are delocalized. And since they're delocalized, firstly, there are no ions, so this is a complete cross. They cannot be arranged in such a beautiful manner in straight lines. No, they're delocalized. They have to be randomly arranged. And they're not only present in the surroundings of the positive ions, they're also present in between. Okay, so this diagram perfectly shows it. A mixture of 5 cm cube of CH4 and 100 cm cube of air is exploded. Assume that 80% N2 by volume and 20% O2 by volume. The resulting mixture is cooled. All volumes are measured at room temperature and pressure. What is the composition of the resulting gas? Again, I told you that you don't use all the thing and that stuff. You have 5 cm cube of this. 100 cm cube of air contains 20 cm cube of this. Okay, and you have nitrogen is gonna remain 80, right? Oxygen, to react with 1 mole of this, you need double the amount of this. To react with 1 mole of CH4, you need 2 moles of O2. So if you have 5 moles of this, you would because the mole ratio equals to the volume ratio I explained you will require 10 cm cube. So how much is going to be left out of 20? Because you have 100 cm cube of air and 100 cm cube of air, you have 20 cm cube of O2. And since you have 20 cm cube of O2, out of the 20, you only use 10, so 10 is left. So 10 cm cube of O2, yes, 10 cm cube of O2, 5 cm cube of carbon dioxide. what is the composition of the resulting gas? Yeah, since this is 1:1, so if you're using 5 cm cube of this, you're going to form 5 cm cube of this as well. 10 cm cube of steam, no. You know why you're not going to form steam? I told you all volumes are measured at room temperature and pressure. Room temperature and pressure means that steam is not going to be produced. You're going to form water in liquid, because at room temperature water becomes liquid. So it's option number B again. The diagram shows the outer shell electrons of the atom of two elements Q and R. The sulfate of Q is insoluble. Okay, Q sulfate, I know it's barium, because look, 2 electrons in the last shell tells me group 2 sulfate, insoluble barium sulfate. Proton number barium, I think it's 56. Okay, I think. The relative atomic mass of R, element R is gaseous at room temperature. 1 2 3 4 5 6 7, so it's in group 7. Since it's in group 7, gaseous, obviously chlorine, because bromine is a liquid. 80 is going to be for bromine, and bromine is a liquid, so option number D. Look, it was a little tricky, but you know, you can do it when you understand the concepts. Gas P decomposes to form Q, so X moles of P are decomposing to form Y moles of Q. 2 experiments are carried out to investigate the rate of the reaction. The conditions are the same, except that 2 different temperatures T1 and T2 are used. Okay. T2 is a little less, because look, over here the line is a little steeper. That means T1 is a higher. Over here it's a little bent. You can see it. And over here you can see we reach this at almost this much time. We reach quickly. We form the product very quickly over here, like at this much time. And over here we're forming the product at this much time. So T1 is higher. T1 is higher. T1 is higher, because at high temperature you form the product quickly. Now what do? We look at the boxes. We have 1 box, 2 box, 3 box, 4 box, 5 box, 6 boxes. We have 6 boxes of Q, and then we're forming how many boxes of... We have 6 boxes of P, and then we're forming how many boxes of Q? For Q, we're forming 6, 7, 8, 9. We're forming 9 boxes of... 9 boxes of Q. So we have 6 boxes of P. Since it's gas, the volume ratio equals to the moles, and 6 and 9. 2 times, 3 times. X equals to 2, Y equals to 3. X equals to 2, Y equals to 3. Again, I'm going to tell you what you have to do. You have to calculate the boxes. Why? Because the boxes tell the volume. And in gases, I told you the volume ratio equals to the mole ratio. Over here, for X and Y, you need to figure out the moles. For X and Y, I calculated there were 6 boxes for X and there were 9 boxes for Y, and I understood it's 6:9. That becomes 2:3 if you cut it on the table of 3. Got it? Next, dissolved substances can cause eutrophication. How many of the ions cause this effect? We know that nitrates and phosphates cause eutrophication because they provide nutrients. So only 2, chlorides, no, carbonates, no, sodium, no. Which piece of apparatus would be most suitable for measuring this much of aqueous ammonia? You know that burette. Why not pipette? You would be like, oh my god, this is such an exact volume. Then why are we not using pipette? Because a 50 cm cube pipette has an exact fixed precise 50. It can not measure anything except 50. A burette can measure 25, 26, 27, 28, 29, 46, 45, any value. But a pipette can only measure 50 or nothing else. Okay, so we're going to use a burette. And since the precision is a little more, that's why we're not going towards a measuring standard. It's like not this much precise. Butene reacts with bromine. Which compound could be made? Again, a brilliant question. Always remember, whenever you have a carbon-carbon double bond, something like this, you break this bond. 1 bromine attaches here, 1 bromine attaches here. Now, look at option A. How can a double bond in butene be broken and both the bromines attach on the same carbon? How is this possible? You put double bond between the two carbons. When you break it, one bromine goes on one and the other goes on other. So that's incorrect. If you look here, how is this possible that there can be a double bond between carbon 1 and 3? Either it's between 1 and 2 or 2 and 3. So one bromine here, one bromine here. How is this possible? This carbon and this carbon that are not even touching each other, they form a double bond. That is not possible. Okay, so this is incorrect again. This, how can first and the last carbon form? So it's going to be this. There was a double bond here. Got it? How many structure isomers with C4H10O are alcohols? We would have to draw them. C4H10O are alcohols. 1, 2, 3, 4. OH on the first carbon. Then I have 1, 2, 3, 4 OH on the second carbon. Then what do? I do 1, 2, 3. There's a C here, OH over here. And then can I draw another one? Let me see. What if I put the OH here? What if I do this? What if I do this? Then 3 carbons here, 1 carbon here. Then I'm going to consider this as my longest chain. Second one has a branching, and the second one has an OH as well. So 1, 2, 3 carbon OH. So 1, 2, 3, 4. Which statements about the alcohol this are correct? When this is oxidized, it forms propanoic acid. So is it propanol? 1, 2, 3. Yeah, that's propanol. Propanol oxidized from propanoic acid. Propanoic acid reduced from propanol. This burns in air to form carbon dioxide and water. Yeah, that's correct. This can be formed by the addition reaction between ethane and steam. No, between propene and steam is going to form your propanol. So 1 and 2 only. And we have only 95 questions. That means we're done. Bye-bye.